For decades, artificial intelligence operated as an advanced filing system. It excels at analytical tasks, like scanning medical images to classify data and flag irregularities. Traditional machine learning models are incredible at identifying patterns and predicting outcomes based on that existing data, but they operate on strict predefined rules. They cannot create anything new. But today, software systems that only understand mathematics are generating completely original, human-like text, computer code, and art. Modern deep learning algorithms now use those learned patterns as a basis for synthesizing original text, images, and audio. So, what actually happens inside a model's architecture in the few seconds between submitting a text prompt and receiving a brand new response? The mechanics trace back to 2017, when a specific structural design shifted how software parses human language. Tracking a prompt through this specific architecture identifies the mechanical checkpoints that turn human instructions into machine-generated completions. It all starts with the prompt, the initial text or set of instructions you give the model. That text is fed straight into the transformer architecture. Older language models read sentences sequentially, one word at a time. The transformer processes data side by side. It evaluates thousands of elements simultaneously, parsing massive blocks of information at the same time. Running parallel calculations requires immense power, relying on specialized hardware called graphics processing units, or GPUs, packed with thousands of cores for concurrent math operations. This structural leap from linear reading to massive parallel processing provides the mechanical foundation required to chew through petabytes of web-scale data in milliseconds. Inside the transformer, the encoder maps relationships to determine true context rather than just reading individual words. Using a self-attention mechanism, it assigns numerical weights to calculate the exact mathematical relevance of every word in your statement to the others. Once that context is mapped, a separate component called the decoder takes this highly detailed web of numerical weights and begins formulating an appropriate response. Large language models do not comprehend human language. They navigate the statistical probability and mathematical proximity of our ideas. But these pre-trained foundational models have a blind spot. They only know the original data they were trained on, meaning they lack access to your company's private records or today's breaking news. To inject missing context, Retrieval Augmented Generation, or RAG, converts external documents into numerical vectors. These are stored in a vector database for instant semantic search. Upon prompting, RAG retrieves relevant vectors and injects them directly into the model's active memory. It acts as a live bridge, connecting a static foundational model with the dynamic real-world context it needs to be accurate. With all the necessary context in place, the model performs inference. This is the final computational step, where it predicts the exact sequence of the newly generated text. The result is the completion, the final, highly tailored output delivered back to your screen. This entire cycle of encoding your prompt, retrieving external vectors, and decoding the output happens almost instantly. Every completion is a live orchestration of mathematical probabilities, synthesizing unique content on the fly. This processing pipeline solves a massive problem for modern business. Between 80 and 90. By combining generative AI models with comprehensive cloud data platforms, organizations can finally turn all of that unformatted information into highly actionable fuel. This allows companies to automate personalized content creation, reason through thousands of complex medical records in seconds, and seamlessly translate natural languages across global markets. These architectures extract meaning from dormant repositories of raw data, producing tailored treatment plans, optimized software code, and personalized business insights.